Hello. In this video, I'm going to talk about GraphQL error and response handling, which is quite different to REST error and response handling. And that's why I think it's a good idea to talk about this. Before we go into the details, I just want to show you how a GraphQL request is normally processed. Of course, we start with a client that sends a request or a query. And the request then comes into our HTTP endpoint /GraphQL typically. This is probably a servlet or something like that. In Spring, it's Spring MVC or Spring Web Flux. And then we have our GraphQL framework, Spring for GraphQL, for example. And the GraphQL framework parses the query, validates it, so just to make sure that it matches your schema, for example, that there are no syntax errors and so on. And then the GraphQL framework calls your resolver or handler functions. And the resolver or handler functions are responsible for getting the actual data for the request. And then the data that your handler or resolver functions returns are validated by the GraphQL framework again, so that you, for example, do not return null values where null is not allowed according to your schema. And then the response is built here in this framework and is sent back to the client. And then the client got its result. And this is the success case. But of course, in many places here, it's possible that there are errors. For example, the HTTP endpoint or the server could have out of memory, for example, and the HTTP endpoint cannot handle the request and will maybe return HTTP 500, for example. Or the GraphQL endpoint is secured somehow so that you have to send a token or something like that with your request, and the token is invalid. So then the HTTP endpoint would return something so that the actual query is not processed at all, but the client gets back an error message. When there are no problems in the server and you're authenticated correctly, then the GraphQL framework starts processing your request. And we already talked about that. Here, the query the client sent could have a syntax error, could have a query error that the query does not match your schema, for example. Then again, the client gets an error. And also, of course, your handler functions can fail. For example, you want to access a database, then the database is not available, or there's some other programming mistake, or the data sent by the client is valid according to your schema, but is invalid according to your domain data. For example, it references an entity that does not exist or something like that. Or it sends data that is too long. For example, you have a restriction that a title of a new blog post can have a maximum of 200 characters, but the client sends 500 characters. Then your handler function would fail and the client needs to get an information that something went wrong. To see this in more detail, let's go to IntelliJ. And in IntelliJ, I prepared a GraphQL or HTTP request with a GraphQL query inside. And this HTTP request will make my server fail because I added this error equals true flag here. And if my server receives a request that has this request parameter set, then it throws an exception so that we can simulate a really bad server error, like for example, out of memory in real life. I will run this query here or this request, and in the response, you see what we get is an HTML page, and that is the normal Spring Boot error page that is returned when a request could not be handled. There's nothing special, nothing with GraphQL here. That is normal Spring MVC error page. And we see our error here in this stack trace. This is my dummy error that is provoked by this query parameter. So when your server cannot handle the query, the request at all, you get the normal Spring error back. We can remove this error here, and then I run the query again. Now you see we have no response at all, and we have a response code of 401. And that is because my /GraphQL endpoint is secured by Spring Security, and we can only access this endpoint if we send a valid credential with our request. So the request is not forwarded to the GraphQL framework because we have missing credentials, and in this case the server returns 401. Let's fix that problem. I enter or I insert an authorization token here, and the authorization token is a valid token, and so we should be allowed to run our GraphQL query now. You see, we got response code 200. Our query is executed successful, and we also get the data node in our JSON response, and the data node contains the data that we have queried here. So this is a successful GraphQL query. Let's have a look at another example. I prepared a mutation here, and this mutation also needs a token, of course. So I enter or I insert the token also here, our bearer token here. And let's see what happens if we run this mutation. We see, at first we have response code 200. So the server says the response is okay. The response code is okay. But if we look at the actual response that the server sends, we see we have data null, but we have an errors object here. In fact, it's a list of errors with only one entry in this case. And the errors object is always returned by GraphQL if the GraphQL framework was able to read your query, but not to execute your query successfully. In this case, you get back HTTP status code 200, no data probably, depending on your query, but in many cases no data, and then one or more error objects. And this is very, very different from REST API, because in REST API you always get a 400 or 500 error code if something went wrong. In GraphQL you might get HTTP code 200 back, and inside your response you then have an errors description. The error objects that are contained in this errors array are not really specified in the GraphQL specification. That is more or less a recommendation how these objects should look like. And in Spring for GraphQL, they follow this recommendation. They have a message, which is just a user-readable message. They have a location. The location points to the place in your query where the problem occurred. In this case, it's line 1, column 13, and this is where the mutation starts here. This is column 13. They also have a path, and the path points to the field that leads to the problem. In this case, it's our add_vet field here, but it could also be add_vet.id when the ID field from the response raised an error. And we also have an extensions field, and this extensions field is populated by your GraphQL framework, in this case Spring for GraphQL, and Spring for GraphQL adds a classification for you or for the client so that the client can somehow interpret maybe this error object. In this case it's forbidden because we have sent the wrong credentials. In Spring for GraphQL, or with Spring for GraphQL, you can slightly change the behavior of this errors field depending on your needs. You can register an exception handler, and the exception handler then transforms an exception in this errors objects here. You can add your own classifications, you can add your own extensions, and so on and so on. But in general, the errors object should only be used for technical-like problems that the client most probably cannot handle itself, or that are very general. It's maybe a little bit comparable with uncaught runtime errors or with runtime errors versus checked exceptions. So this is maybe something like a runtime exception in Java. The server was not able to process your request, but it at least tries to start processing the request, and then it fails, and then it returns this errors object. Let's go to GraphQL, and in GraphQL I prepared the same mutation that we have seen in IntelliJ just before. And if we run it here, I have to log in. And now I log in with another user, and this other user, Susie here, is allowed to execute this mutation. So I run it, and you see we got the result back here, data and the new created veterinarian in this case. The GraphQL API I'm using is from the Spring Pet Clinic GraphQL example. So in this case, there was a success. Of course, we get back HTTP status code 200, but more important, we get back our data. And if we go back to our Miro board here of this request chain here, we have handled this case, we have handled this case, we have somehow handled also this case, because remember, when we executed the mutation for the first time, our resolver function failed because it was invoked with invalid or insufficient credentials. Now we have another situation where problems can occur. Inside our handler functions, note that in our unauthorized example, the handler function, of course, is not invoked at all because Spring Security forbid to invoke the handler functions. But now let's assume we can invoke the handler function, but inside our handler function, an error occurs. Therefore, to show you that behavior, I change this mutation and insert different IDs here. This IDs 7 and 9, parentheses, IDs in our database, and the ID 7 and the ID 9 are not available in our database. So when I run this query, we again get no data, but we get an error object. In this case, it's another error. It's not forbidden, but it's an internal error because some uncaught exception was thrown in our handler function. I will get to this in a minute. The message is something that we don't understand. And again, we have the path and we have the location that is the same as before. But the difference here is that this problem here that we specify, or that the client specify invalid IDs, is maybe not a technical, but more a business error that could be handled by our server and could return to the client in a better way. The same would be true, for example, let's say that we have a UI where the user has to enter its first name and its last name. And we have a credential, we have a requirement that the last name has to be shorter than 10 characters, for example, or 20 characters, whatever. And the user enters a last name that is 50 characters long. Then the server should be able to return a very specific error message or an error description, what went wrong, so that the client can, for example, display a readable error message so that the client can render an error UI so that the user can then fix its problem. So for these cases where the client should handle or should react on this error, this errors object is not enough. It's too unspecific. Also, an error object is not described in your schema. It always looks more or less the same. And there's no use case specific documentation or something like that, or use case specific schema for these error objects. If you want to make error handling based on your use cases, based on your fields, based on what's happened, based on your handler functions, then you can change the behavior probably of your fields. And that's what I want to show you now. Let's go back to IntelliJ and let's have a look at our schema. And in our schema, we have this add_vet mutation, and the add_vet mutation returns the new created veterinarian object, or short vet object. The problem is when inside the add_vet mutation an error occurs that we handle in our handler function for the add_vet mutation, we have no way to communicate the error back to the client beside of the errors object. But what we can do now is we change the return type of our mutation, and I think you should do this when you start building your API, that you never return the business object itself directly from your mutation, but a payload object. And this payload object could be something like that: add_vet payload. Of course, it's mandatory; it cannot be null. So using this add_vet payload type, we can add more informations for the client. Type add_vet payload. Maybe we return the new vet if the mutation is successfully. Maybe we return an error message if it is not successful. That would be a very, very simple return object. And even better it would be when we're using a union type in this case, because a union type allows a field to return not only one type, but multiple types. In this case, it would be, for example, nice if we have an own type when the vet could be created and another type when there was an error, because that is easier for the client to understand. And also we then can make these fields mandatory. So let's make a union type out of this. This is as simple as this: union @vet payload equals @vet payload success, for example, or @vet payload failed. And our @vet payload success type is this one, and our @vet payload failed is this one. And the names are not really nice, so I rename this to @vet success payload, and I rename this to @vet failed payload. So in this case, the server can return either this type or that type, depending on the outcome of our handler functions. And in these types, we can use mandatory fields because we know when the operation, when the mutation was successful, we always have a new veterinarian. And also, if the operation, the mutation failed, we always have an error message, so we can make these fields mandatory. And if we later want to enhance our error handling, for example, we can just add new fields here. For example, something like that. If we have an error code, maybe we also have a list of fields that failed. Whatever, we can add more fields to this type, and this is a backward compatible change. Let's go back to our mutation. You remember when I opened the GraphQL schema, the schema looked like this. We just returned the domain object. When you now change the return type of a mutation or another field, in this case to @vet payload, then this is a backward incompatible change. Existing clients must update their GraphQL queries, existing clients that are using the @vet mutation. So if you're starting a new GraphQL API, if you're adding new mutation, I would recommend that you always start with union types as the return type for your mutations, at least for your mutations. Of course, also in other cases, there can be problem in other fields, but I think that at least for mutations, you should start with payload types, with union types, because chances are high that you need some error handling in case of mutations. If you start with just an object, so we, as we did it here, we started with type @vet payload, and then we had the type with vet and error message. And then you later change from a type to a union type. This is also backward incompatible. So I would recommend that you start with a union type. And by the way, a union type can also consist only of one type. So if you just want to start with a success type, then you can use a union type anyway. And then you're backward compatible if you add new types here to your union type. So this is my recommendation. If you have and this is not only my recommendation, also other people are recommending this. If you have a mutation, design a union type, a payload union type for at least for success and failed. So of course we have to implement that, and for that I'm going to my vet controller class, and in this vet controller class you see the mutation mapping for our @vet mutation, and we will make this very, very simple here. I will create a new record here that is called the same as our GraphQL type, and this contains of the new vet. This is the success case, and then we have the @vet failed payload, and this has an error message. And that is the case when something failed. Now in our mutation mapping, we just add error exception handling here. And if our mutation fails, we catch the exception and we just return the @vet failed payload and pass in the exception.get message. Of course, in many cases, you would make some better error handling here. For us, for our demonstration here, that is enough. So, and in the success case, we return a new instance of @vet success payload and pass in the new vet. So we can save this, we can rebuild our application, and then we go to our GraphQL. I reload the page, and you see we have this error here now because the mutation does not return the vet anymore, but the union type. And if a field returns a union type, the client has to explicitly select the fields from the union types it wants to have. For example, in this case, we want from the add success payload, if the mutation is successful, we want the vet, and from the ID, from the vet the ID. And if the mutation fails, we want the failed payload. And in this case, we only have the error message. And now we return, we re-execute the mutation. And you see, we now have data, no errors anymore. We have data. We have our mutation here, that is this field here. And we have the error message because our mutation still fails because these IDs are not in our database. But we now have a better error message for the client. That's debatable. But of course, you could build better error messages, better error informations for your client that the client can use to handle the error. And just to make it complete, we run the mutation with successful data. And then we see here we get our new vet with the new ID 7. So that is, I think, an important point when you handle GraphQL errors. We have the difference between this like runtime errors, or when your request cannot be handled at all, then you get the HTTP status codes that are not 200. When the request processing failed, then you get an errors object back, HTTP code 200, but errors object. And when you want to make some own error handling, some business error handling, then you can use union types to indicate the client that something failed. And if you're using union types with Spring for GraphQL, there's one important point that you have to keep in mind. In this case, our GraphQL types add success payload and add failed payload matches the names of their Java counterparts. If the Java class names do not match the name of the GraphQL type names, then you have to build a type resolver, and I can show you that. Let's say this add success payload type in our Java world is not called add success payload, but it's only called add success. I rebuild and I rerun the query. And now you see we get again a technical error from our GraphQL framework in this case, that it can't resolve the add because the abstract type add payload, that is our union type, must resolve to an object type at runtime for field mutation add, and we could not determine the exact type of add payload because Spring for GraphQL or GraphQL Java does not know that this add Java class should match the add success payload GraphQL type. And if you have such a situation, such a mismatch, there are several ways how you can handle this. And one simple way is to create a new configuration. I call it GraphQL configuration, and we annotate it with configuration, and we register a new bean. This bean is of type GraphQL source builder customizer. The GraphQL source is the central configuration object of GraphQL in Spring for GraphQL, and the builder customizer is the customizer for the builder that then creates the GraphQL source object. This is a common pattern in Spring Boot, I think. And in this function, we can create a new class name type resolver. And the class name type resolver maps Java classes to GraphQL class names. There's a default class name type resolver registered in your GraphQL application if you don't do anything. But if you want to customize this, one way is to instantiate your own class name type resolver. And then we can invoke class name type resolver dot add mapping. And here we add the name of our Java class, or the Java class itself in this case, and that is vetcontroller.add success dot class. And this add success class is in GraphQL the add success payload type. And yet now we have our class name type resolver configured here. We can return the builder, and on the builder we have the default type resolver, and we can set our own type resolver here. So I rebuild our application for the last time, and then we rerun our mutation, and you see now it works, because now Spring for GraphQL knows if our handler function returns an add success class or an instance of that class, then this matches, or this is the add vet success payload type in GraphQL. So that's it for now for error and response handling in GraphQL. Remember, HTTP status codes does not play a big role in GraphQL. It's only when something completely goes wrong, then the status codes are relevant. Like, for example, the HTTP endpoint could not be invoked because the server has a problem or you are not authorized. But if the request comes behind your endpoint and reaches the GraphQL layer, then HTTP status code will always be 200, and you either get data back, or you get errors back, or you get data and errors back. Also, this is possible. And the errors object more or less should contain technical errors, while all other errors should be handled explicitly in your application. And then you can send back these errors, for example, using a union type in your mutation functions. I hope that was helpful, and I hope we see again. Have fun when building GraphQL applications. See you.